All right, we're on to number 9 here, guys. So we are representing the accompanying graphs as equations. So what we're going to do is we're going to start with letter A. Now remember, these are all absolute value equations. So they all follow the equation y equals the absolute value of x. All right. And in vertex form, it's x minus h and then plus k. So remember, we're moving left and right with the h, and we're changing the sign of the number when we plug it in, and the k stays the same sign, it goes on the outside. So we can see with this being 3, 1, we know that h is equal to 3 and k is equal to 1. So my function is going to be y equals, or f of x equals if you want, all right, the absolute value of x. And we're going to do minus h, so minus 3, and then plus k, so plus 1. Plus 1. All right, so y equals absolute value of x minus 3. And then close the absolute value sign and put plus 1. All right, letter B here. We already did this one together. This one you can tell has a slope of 2. So instead of going 1, 1 all the way like this, we're actually going up 2 and over 2 over 1. So it has a slope of 2. Okay, we don't need that. All right. So I can see the slope is different. So we can kind of count that. So it's a 2 in front. That's our slope. So we're doing a vertical stretch of 2. And then we're moving our h is negative 4, so it's x minus, so we're changing the sign to plus 4. And then our k is 2, we put that number on the end, so it fits in with k here, okay? And the other graph, we're going to change the point to 3, 6, okay, from what it previously was, which was 4, 6. I'll give you both answers just in case. Well, you just switch, honestly, just change the 3 to a 4 when you do this. We're going to check our slope first. We can see that it's just going 1, 1, but this one's actually flipped upside down. So we know that in order to flip upside down, we actually have a number in front. We can put an a here for ourselves. So it's y equals a times the absolute value of, we'll fix that real quick. So the actual function follows that pattern of x minus h plus k. All right. What we're actually doing with our function is we're looking for a in front, then x minus h, and then plus k. All right. So that a in front is our vertical stretch. Also, if a is negative, that means we flip it over the we're flipping it over the x-axis, which is what's happening here. So it's y equals negative 1, so just negative, okay? Absolute value, it's x. Remember, it's supposed to be minus h, so h is 3, so minus 3, and then positive k, so then plus 6 on the end there, okay? All right. Now the next graph is we have the graph of x, f of x plus 1 plus 2. So what we want to do is basically take this graph and perform this transformation. So the x plus 1 inside here tells me that I'm actually shifting left or right, and this is going left 1 because it's positive, and remember it's supposed to be opposite. So the graph of f of x, in order to shift it back to normal, this x has to be negative in order for that to happen. That's why it's going left. Okay, I have to move that over. And then the plus 2 on the end tells me that we're going up 2. So all I'm going to do is pick some nice points that I can graph. So there's a nice point right here. Okay, we're going to pick another nice point, which is this point down there. Maybe this point right down there. Here's another nice point. And then I have these 2 points up here where the arrows are. And so all I'm going to do is shift those points, okay, left 1 and up 2. So left 1 up 2. So there's that point it's going to move to. Left 1 and up 2. There's that point. Left 1 up 2. Left 1 up 2. And left 1 up 2. And so now my graph has been shifted. All those integer value points, so all the points that have integer values, I've moved. And now I'm just going to redraw my curve and throw some arrowheads on. Remember, this is a curve down here. It's not like a V, so it's going to make a little curve. Okay, and there you go. That's all I have to do. Find some nice points, move those points using our transformation according to the equation, and then go ahead and draw the line. Number 11, Nora inherited a savings account from her grandmother she was born. Consider the following function. So remember, this is supposed to be a of t is equal to And we're normally supposed to put down the initial amount, okay, times our growth factor, raised to the t, which is an amount of time in years. The initial investment is that number we put in front, so that's 5,000. The rate the money increased by is our growth factor, right? That's actually 1 plus r is what's going in here. So if this is 1.03, that means our rate is equal to 0.013 as a decimal, and then all we have to do is multiply times 100 or shift the decimal point over 2 spots, and we get 1.3% as our rate. So the rate, all right, R, right, is increased by 1.3%. If you wrote 0.013, I would also give you credit because those two numbers are equivalent. How old is Nora? Remember, it said she started when she was born, and she's currently 25. That's on her birthday. And the value of her account, we're just going to take our calculator, so pause while you get that ready. So we're just going to type in, so we have 5,000 times 1.013. Oh, that's not where that's supposed to go. Over here, parentheses, 1.013, 0.13, okay. And then raise to this, we get the caret button there, and then 25. And we get $6,905. Remember, it's money, it's going to round to the nearest cent unless it says otherwise, and it doesn't. So, dollars, $6,905, decimal point, and then we have 68 cents. So be careful that it doesn't say like round to the nearest cent or nearest dollar or $10. Just make sure you round accordingly there. All right, a car was purchased for $25,000. Research shows the car has an average yearly depreciation, so when it's going down, rate of 18.5%. So remember, we know that as a decimal, that R value is going to move 2 decimal places to the left, so 0.185. All right, and determine the value after t years. So this goes down per year, so I know that I can use this function, ab to the x, or if you want to use the other one, remember that's p equals, or a equals, sorry, the amount. A equals p, parentheses 1 plus r over n raised to the nt. All right, so we did the first one. So we're going to do y equals, this is A, so A is our initial amount, that's $25,000. Now B, if you remember for depreciation, is going to be 1 minus R. So B is going to equal 1 minus 0.185. So if this were 19, it would be 81. So this is 81.815. And we can still grab our calculator for this. 1 minus 0.815. And we're going to get, I did that backwards. 1 minus 0.185 and 0.815 back. All right. So that's going to go in the parentheses, 0.815. And we want to know how much will the car depreciate from year 3 to year 4. So here's my formula, okay? And then now you got to be careful because in the question, you can see right now, I'm making an error. It says v of t and t. So I know that instead of writing this equation, I need to write v of t where y is. So 25,000 times 0.815 to the t. That is the equation I need to write here. Okay, so we need to do this for the year 3 and then year 4 and basically subtract them. So first we'll do v of 4. So same formula, 25,000 times 0.815 to the 4th. We'll get that amount. So v of 4 equals, and we'll figure that out. And then we have to do v of 3, which is 25 G's times 0.815. That's a terrible 8. We'll fix that one. I also need about a 0. 8. Not much better. We'll take it. 1. 1. 5. Get out of here, you. To the third. And we'll figure out what that is. And then we will subtract. All right. So, calculator. Where are you at? 25,000 times 0.815 parentheses caret 3. I'm immediately going to go up and grab that last equation and just change the 3 to 4. And I have my two numbers. So 11. Now, this says the nearest cent, so we never round a few. So $11,029.87 for 4. $11,029.87. And then $13,533.58. 13,533.58. All right, and then we just got to subtract them. So I'm going to go up here. I'm going to grab this first number. We're going to round it down. I'm going to grab the second. Oh, we're going to put a minus. Go to the second number. We're going to round it down. And I get $2,503.71. So it will depreciate. Tummy hurts. I'm sorry. Okay, I'll be right with you. You can say hi if you want. What's your name?
Me.
Your name is me? Who gave you that name? I did not.
Me.
You gave yourself me name?
Me. Me.
All right, there you go. There's our amount. All right. You want to draw a picture for everyone real quick? Get it quick. Go ahead. Oh, it's not on a pen. All right, draw a picture. Go ahead.
Happy.
Love it. Thank you. All right, let's go get some food. Pausing. All right, so what is the formula for the nth term of the sequence? So the first thing we have to decide is this arithmetic? Is it geometric, right? And we can see as we go down, we're definitely not adding the same amount. We're actually dividing. So here we're dividing by 3. We're dividing by 3. Or you can consider this actually, right, multiplying by 1/3. Okay, so that is our R value is 1/3. Okay, so we know R is equal to 1/3. We know our first term in the sequence, which is A1, right, is 54. And so now I can write a formula for the sequence. So my formula, okay, is going to be A sub n is equal to the first term, so 54, times our R value, which is 1/3, raised to the n minus 1 power. All right, that is it. So that's our general term that we're using, and we will go from there. Use your formula to find the 8th term. So we're just going to plug in 8 here. So A of 8 is equal 54 times 1/3. And it's essentially just 8 minus 1, which turns into 7. So A8 is equal to 54 times 1/3 raised to the 7th power. Now, keep in mind, this is the first term. So actually, the y-intercept, 0, I would actually multiply 54 by 3 to get there. So what's that? 12, carry the 1, 16, 162, all right, is actually the y-intercept. So the other way to think about this one is that this is equal to 162 times 1/3 to the x. Like that's our formula. Because 162, right, times 3, or times a third, getting off track, but that's 54. And then we add times a third again, and we keep going down. So you got to go a term before to get the y-intercept, but this is our first term. So keep that in mind, okay? But we're using this equation, going back to it. So I just do 54 times, and I'm going to do 1/3, so 1 control, divide for my fraction bar, and then raise that to the 7th power. And I get 2 over 81. So a sub 8 equals 2 over 81. All right, and if you wanted to, I could click Control Divide, and I would get that as a decimal, which is that crazy thing right there. Arithmetic sequence. So we have some numbers. We want to know the formula. So remember, if I want to get the a sub n, I know my formula is a1 plus n minus 1 times d. So I essentially need to know for this, okay, these two things. I need to know a1 and I have to know d. So to figure out d, we can kind of think of this as a line of terms. We know the fourth term is 19. Fourth term is 19. And the seventh term, so 5, 6, 7, is 31. So what I really want to know is what do I have to add to get from here to here? And I'm doing it 3 times. So I just kind of take the sum and I just divide it by 3. That's it, or the difference really. So 31 minus 19 is 12, and I need to multiply something times, right, 3 times to get 12. So we just basically take 12 and divide it by the number of spots. And so I would now know, right, that I'm actually adding 12 to get here. So that means I have to add 4, right? So I'm adding 4 plus 4 here, okay? To get from there to there, I'm adding 4. And then to get from there to there, I'm adding 4. So I'm just doing 12 divided by 3 there. So now I know d, right? D is 4. And now I can work backwards from 19. So minus 4 gives me 15, right? Go 4 back, it gives me 11. Go 4 back, gives me 7. And now I know the first term. And there's a1. So now I can write my formula. So a sub n is equal to the first term, which is 7, plus, and then it's n minus 1 times 4. And just in case it's multiple choice, remember we're going to have to kind of distribute here to get this through. So if I distribute the 4, the other way this would look is 7 plus 4n minus 4. And then I can combine the like terms of the negative 4 and the 7. And I would end up getting an equation of 4n plus 3. So this is my equation in function notation, and this is my equation written in explicit form. The answer could be in either one of those forms, so it's up to you. 15, if the pattern below continues, write the explicit and recursive formulas. So, do we have to answer anything else here? No. So we can see that this guy has 3 terms. Here I have 5. And then we're taking those 5 and we're adding on these other 2. So this is 7. And then we're taking those 7 and we're adding on these 2 more, right? So we get this 3. So we can see this is arithmetic, right? And that I'm basically adding 2 to get to the next term. All right. All right. So we need to write the explicit. So remember that's an. So an equals first term plus parentheses n minus 1 times d. So now we know the first term in the design has 3 terms, and that d is equal to 2 because I'm adding 2. So a sub n equals the first term, which is 3, plus n minus 1 times the common difference, which is 2. And if we want to get in function notation form, I'm just going to distribute. So 3 plus 2n minus 2, and then combine like terms. So it's an equals 2n, right, minus 1. So I would either accept this formula in the explicit form or this formula, which is in our standard linear equation form. All right. The next one is recursive formula. The recursive formula is nice and easy. Okay. It is an equals the term before it, which is a sub n minus 1. And since this is explicit, right, since this is arithmetic and we're adding, we're just going to put a plus 2 on the end. That's it. That's our recursive formula. Okay. So it's the an, a sub n, and then a sub n minus 1, and then just plus 2. All right, what is the common ratio for the first term, who is 27, and the fourth term is 64? We're essentially doing the same thing here. So the first term is 27, the fourth term is 64, and so I need to do times r, and times r to get to 64. So 27 times r times r times r is equal to 64. This would be 27r to the third, and then we would just solve this equation. I will not ask you something like this tomorrow. I will ask you something about the arithmetic one though. So this is r cubed is equal to 64 over 27, and then we're just going to take the cubed root to get r by itself here. And so if I take control and I want to press caret to get this one, we're going to put a 3 instead of the check mark, and then we're going to type in our equation, our number, which is 64 over 27, and we can hit enter, and it'll tell us that this is equal to 4/3. So I have to multiply 27 by 4/3 3 times to get 64. So 27, right? And then we do times 4 over 3, and we can see 36. Okay, 27. Now we're going to do that number times 4 over 3, it's 48, and then times 4 over 3, there's our 64. So you can kind of see how that works. All right, last one of the day. What is the 15th term in the sequence? So we want to ask ourselves, are we adding or are we multiplying? And we can see that we are actually multiplying here to make this happen. And I actually need to be multiplying by -2 to make this happen. So I'm multiplying everything by -2. So in our terms, we need to know A1, which is 5. We need to know our common ratio, which is -2. And then I can write my sequence. So A sub n is equal to the first term times r to the n minus 1. So A sub n is equal to the first term, which is 5, times -2 to the n minus 1. And then I'm going to find the 15th term. So A sub n is equal to 5 times -2. We know that we're going to do 15 minus 1, which is 14. And then I actually want to switch out the n here for 15. Okay. Hold on 1 second. Okay. So we take the computer calculator, we do 5 times -2, and then we do caret 14, enter, and there's our answer. So it is 81,920. 81,920. That's 15. All right, that's it, guys. So tomorrow, make sure you know how to do the calculator for the exponential regression. You are familiar with changing the graphs and identifying the transformations, and that you know your sequences and explicit and recursive. And I'll make sure to give you those formulas. All right, and Kate wants to say bye. Is that it? Bye, bye. All right, later, guys. Kate.